Hello guys, and welcome back to Pre-Calculus. We're going to continue talking today about some vectors, and the first thing that I want to talk about is just an alternate way of writing a vector's component form. So we know component form of a vector looks like this. Okay, and basically the component form of a vector represents how the vector moves both horizontally and how it moves vertically. So the component form doesn't tell you what the two endpoints of the vector are, but it does tell you basically how far it moves and in what direction. So that's all you really need to know about vectors. Now, there's another way of thinking about vectors, which is movement on the x-axis and movement on the y-axis, which is the same thing, except it's just written a little bit differently. So to do this, we need to understand the concept of I and j. Now, this I is not the I that we use for imaginary numbers. It is a totally different thing just for vectors. Now, what I represents is a component vector of 1, 0. So I represents moving one place to the right. J represents the vector 0, 1. So now, if you use those, then any vector can be written in the form AI plus BJ. Now, AI plus BJ is the same thing as the component vector AB. It's just written as you're moving A in the I direction or in the right or left direction, and you're moving B in the up or down direction. This is called the linear combination. If it ever says write the linear combination, or you're given a combination of I and J with a plus, then that's what you need to do. Now, here's another explanation of why that is. So if you're looking here, if you're given the vector AB, well, you can think of the vector A as the vector A, comma, 0. And plus 0, comma, B. So you can think of the vector as the sum of those two. Give me 1 second here. Now, you can also think of, if you want to take these out, you can write this as A, if you take an A out of here, times 1, 0, plus B times 0, 1. And now we know I is 1, 0, so this is the same thing as saying AI plus B, and then J was 0, 1, BJ. So basically, this is just an explanation for why this works. Okay, so the first thing we're going to do is really simple. We're just going to convert vectors into this form. So don't overthink it. If you have the vector in component form 2, 5, you can write this as 2i plus 5j. These are the same thing. Basically, the vector component form 2, 5 means you move 2 to the right, 5 up. 2i plus 5j means the exact same thing. And negative 7i plus 3j. And then, for these two, you got to remember, these are actually giving you the endpoints. So we actually don't even have the component form yet, but you have to remember, these linear combinations that we have here, these additions here, are actually using the component form. So the first step for this is going to be, we want to turn that into component form. So you do subtract the x's and subtract the y's. Negative 5 minus negative 9 is 4. Negative 6 minus 8 is negative 14. So now you can write it as 4i minus 14j. It's plus negative 14j, which you can just write minus 14j. Okay, so if you're given it like number 3, you just got to do the component form first and then do this. So next one's the same idea. -2 minus -10 is 8. 5 minus 6 is -1, so this is going to be 8i minus 1j, or you could just write j. So this still means write 8 down 1, but it's just in a different form. All right? Today is very, very short, so this is where we're leaving this. We are going to do the trigonometric forms tomorrow, but at this point, just watch this video. Make sure you finish up anything that you needed to get done, and after tomorrow I will be posting some problems for you to work on for all the vector stuff that we've been doing.